Welcome to the United States Sports Academy, America's Sports University. This is Unit 5 of Math 465, Statistical Measurements in Sports. This unit covers the fundamentals of statistical inference. It is important to note that this presentation is simply a summary of the topics covered in Unit 5 and not intended to replace the textbook or any supplemental readings.
Welcome to Unit 5 of Statistical Measurements in Sports. This unit focuses on the fundamentals of statistical inference and covers topics such as confidence intervals, type 1 and type 2 errors, as well as one-tailed and two-tailed tests for hypothesis testing. This is a very important unit for you to understand, especially for those who are interested in getting into a profession that will involve some level of research. The key terms that you should familiarize yourself with are sampling error, standard error of the mean, confidence intervals, as well as the alpha level. The main things that you want to learn in this unit are the key terms that I just mentioned. You also want to be able to choose between one-tailed and two-tailed tests for hypothesis testing, and you also want to understand the concepts associated with hypothesis testing. If you have any questions, any concerns, please by all means contact your instructor. Thank you.
After successfully completing this unit, you should be able to 1. Estimate sampling error. 2. Understand confidence interval and alpha level. 3. Identify type I and type 2 errors. 4. Understand the difference between a one-tailed and two-tailed test. Here are a few key terms to remember in this unit. Sampling error refers to the amount of error in the estimate of a population parameter that is based on a sample statistic. Standard error of the mean is a numeric value that indicates the amount of error that may occur when a random sample mean is used as a predictor of the mean of the population from which the sample was drawn. Level of confidence is a percentage figure that establishes the probability that a statement is correct. Alpha is the level of chance occurrence and represents the probability of error. Confidence interval is the range of values associated with a level of confidence.
In this lecture, I'll be talking about null and alternative hypotheses, and I'm going to start off with an example. School District A states that its high schools have an 85% passage rate on the high school exit exam. A new school was recently opened in the district, and it was found from a sample of 150 students that they had a passage rate of 88% with a standard deviation of 4%. The question is, does this new school have a different passage rate than the rest of the schools in School District A? Now, when we do hypothesis testing, what we're really doing is testing claims. Like for this question, we're testing the claim that students at the new school have a passage rate that is different from the 85% that we would expect. While it would seem obvious that 88% is different from 85, remember when I talked about sampling error. This is a small sample taken from an entire population, so the mean of 88% that we've calculated might not be entirely accurate. That's why we're going to do hypothesis testing to find out if this school is really different from what we expect it to be. Now, the first type of hypothesis is the null hypothesis. That's going to be represented usually by HO or H0. What this is the assumption you're beginning with, or basically the opposite of what you're testing. Remember, we're beginning with the assumption that the school will be at 85%. And also, we're testing to see if it's different from 85%. So the opposite of that would be if it's the same. So we're going to start with the assumption that it will be 85%. And then we have the alternative hypothesis, which is represented by H1 here, and sometimes you might see HA instead of H1. That is the claim that you're testing. In this case, we're testing to see if the school has a passage rate that is different than 85%. We're going to try to find evidence which shows that the null hypothesis is untrue. If this evidence exists, we can reject the null hypothesis and say that the alternative hypothesis is true. If we cannot find this evidence, we will continue on with the assumption that the null hypothesis is true. So for this example, for the null and the alternative hypotheses, the null hypothesis H0 is that the mean is equal to 85%. We're going to start off with the assumption that this new school has the passage rate of 85%, just like every other school in the district. And our alternative hypothesis, H1, is that the mean is not equal to 85%. The claim that we're testing is that this new school may have a passage rate that is different from the expected 85%. So that is hypothesis testing with null and alternative hypotheses.
With hypothesis testing, the researcher either accepts or rejects the null hypothesis. Because decisions are made based upon probabilities, It is important to understand Type 1 and Type 2 errors. Refer to the tables to understand the possible causes of a Type 1 and Type 2 error.
Now before I start talking about Type 1 and Type 2 errors, I quickly want to go over my example from the last lecture about null and alternative hypotheses. So, School District A states that its high schools have an 85% passage rate on the high school exit exam. A new school was recently opened in the district, and it was found that a sample of 150 students had a passage rate of 88% with a standard deviation of 4%. Does this new school have a different passage rate than the rest of School District A? So in this example, the null hypothesis, or basically the assumption we're starting with, is that the mean will be equal to 85%. Now the alternative hypothesis, or the claim that we're testing, is that the mean is going to be different than 85%. So now I'm going to add something. I'm going to say, answer this question using an alpha level of 0.05. So this is kind of what the normal distribution looks like when you have an alpha of 0.05. See that my alpha of 0.05, or 5%, is split equally into two tails. You can have one-tailed and two-tailed tests. I'll talk about that in a future lecture, but here we have a two-tailed test where the alpha is split into two. We have 2.5% and 2.5%. And in the middle I have what's left over, 95%. If you add those three numbers up, you have 2.5 plus 95 plus 2.5, you get 100%. So you can see that we've accounted for all possible outcomes. Now, if the statistic that we calculate, like for example a z or a t, is within that 95% range, we can conclude that what we're testing, usually the mean, is right where we expect it to be, and so we will retain or keep the null hypothesis. The mean is right where we assumed it would be, so we're going to stick with our initial assumption. Now, if the statistic we calculate is outside of that 95% range, we will conclude that what we're testing is not where we expect it to be. And so it's very likely that the null hypothesis is not true. So we're going to reject the null hypothesis and say that the alternative hypothesis is true. Basically, we're going to say, okay, the mean is in this area, and it's so unlikely for the mean to show up here that it's probably here because it is different from the null hypothesis. It's different from what we assumed it would be. So we can conclude that the alternative hypothesis is probably true. It's probably different. So we have the hypotheses here. And now, in reality, the school we sampled from either has a passage rate of 85%, which is our null hypothesis, or it has something different than 85%, which is our alternative hypothesis. So we haven't measured the entire school, we only measured a sample of students. The decision that we make will be based on the characteristics of the sample we've taken and what we know about the probabilities associated with the normal curve. Because statistics don't always accurately reflect the values of parameters, the decision we make may or may not accurately reflect what's real, may not accurately reflect reality. So in reality, the null hypothesis is either true or false. And we're going to make a decision about whether that null hypothesis is true or false. So we could be right, we could be wrong. There are four possible things that could happen. Outcome one is that we reject the null hypothesis when in reality it is false. So what's that saying is that we reject the null hypothesis when we're supposed to. That's good. Outcome number two is that we reject the null hypothesis when in reality it is true. So what we're saying is the null hypothesis is false when actually in real life it was true. That means we made a mistake, and that mistake is called a type 1 error. The third outcome is that we retain the null hypothesis when in reality it is false. So we're saying, okay, we found it to be true, but actually in real life it was false. That's also a mistake, and that mistake is called a type 2 error. And the final outcome is that we retain the null hypothesis when in reality it is true. So really we say the null hypothesis is true when it actually is in reality. So that's another good thing. So there are two good outcomes, and then there's the type 1 error, which is rejecting when you shouldn't, and the type 2 error, which is not rejecting when you should. Those are the two mistakes. So those are type 1 and type 2 errors, and what it means. Now, when you're first starting off with hypothesis testing, you're going to be doing either one-tailed or two-tailed tests. So I'm going to give you a few examples of each, starting with an example I've been using for for a while now. School District A states that its high schools have an 85% passage rate on the high school exit exam. A new school was recently opened in the district, and it was found that a sample of 150 students had a passage rate of 88% with a standard deviation of 4%. Does this new school have a different passage rate than the rest of School District A? So the question right here is, does the school have a passage rate that is different than 85%? This is a two-tailed test because we're testing to see if the mean is either below 85% or above 85%, because it just has to be different. So if the alpha was 0.05, then our distribution would look something like this, with tails on either side because it's a two-tailed test. Now, if the question was higher, does the school have a passage rate that is greater than 85%? This would be a one-tailed test, because we're only testing to see if the mean is greater than 85%. And it would look something like this, with our 0.05 alpha at the top, because we're testing to see if it's greater than 85%. And also we could ask if it's lower, does the school have a passage rate that is less than 85%? This is a one-tailed test because we're only testing to see if the mean is less than 85%. So it would look just like that, with the alpha on the bottom, below the expected 85%. So remember, for two-tailed tests, testing to see if your calculated value is either above or below where it's expected to be. And a one-tailed test is testing only to see if your value is above where it's expected to be, or testing only to see if your calculated value is below where it's expected to be. Those are one-tailed and two-tailed tests. It just specifies the direction of the test you're performing.
Let's review.